Next, the third property deals with the simplification of T inverse of T. That is, inverse trigonometric ratio is outside, trigonometric ratio is inside. This property is the single most important property which you need to master if you want to do questions in advanced exams. So the formula says that sine inverse of sine x is equal to x only if when will sine inverse and sine cancel each other. We have already seen that within a particular domain of sine x, only sine inverse is the inverse of sine. That is, over which domain? Minus pi by 2 to pi by 2, right? So only if this x lies between minus pi by 2 to pi by 2, sine inverse and sine cancels each other. So only if x lies between minus pi by 2 and plus pi by 2. Similarly, cos inverse of cos x will be equal to x if x lies in the restricted domain of cos or x lies in the range of cos inverse. That is, x is in between 0 and pi. Similarly, tan inverse of tan x is again equal to x if x is in between minus pi by 2 and plus pi by 2. That is, within the restricted domain of tan or within the restricted range of tan inverse. Similarly, cot inverse of cot x is equal to x if x lies between 0 and pi. Cosecant inverse of cosecant x is equal to x if x lies between minus pi by 2 and plus pi by 2 and x not equal to 0. And similarly, secant inverse of secant x is equal to x if x lies between 0 and pi but x not equal to pi by 2. So within the restricted domains of the trigonometric functions, T inverse of T of x will be equal to x. Now the question remains, what happens to the other values of x? If x lies between these two, the formula is okay. If x does not lie in between these two numbers, so how do you simplify these expressions? So that's what we need to understand in this property. Now, let us try to understand this concept with a few examples. So if you have sine inverse of sine pi by 6, sine inverse of sine pi by 6. So this pi by 6 lies between minus pi by 2 and plus pi by 2. Because pi by 6 is 30 degrees. 30 degrees lies between minus 90 and plus 90. Hence, sine inverse and sine gets cancelled. So you get answer as pi by 6. Similarly, sine inverse of sine. So without laws of generality, I'll put the numbers, I'll put the angles in degrees just for better understanding. So if I want sine inverse of sine 60 degrees, so this will be equal to 60 degrees because 60 degrees lies in the range of sine inverse. Now let us move forward. Sine inverse of sine 90 degrees. Even now sine inverse and sine gets cancelled, so is equal to 90 degrees. Because 90 degrees also lies in the range of sine inverse. Because the range of sine inverse is minus pi by 2 to pi by 2. Now the question is, what do you do if this angle goes beyond 90 degrees? For example, if you have sine inverse of sine 120 degrees. So what is the actual process of simplification? The problem here is, because 120 degrees does not lie in the range of sine inverse, these two cannot be directly cancelled out. So what we do is, we know that sine x is a periodic function. So sine 120 degrees is a number. So this can be written as a sine inverse of, so what is sine 120 degrees? Sine 120 degrees is nothing but root 3 by 2. So from the basics of trigonometry, we know the quadrant diagram for sine theta. The quadrant diagram for sine theta looks something like this. So sine is positive here, positive in the second quadrant, negative, negative. And the range of sine inverse is minus pi by 2 to pi by 2. So if you have sine 120 degrees, so 120 degrees lies somewhere here. So we know that sine 120 is positive. So I want an angle in the range minus 90 to 90, whose value of sine is exactly same as sine 120. So here sine 120 is positive. So what is the allied angle where? Again, sine has the same value as sine 120. So the allied angle lies somewhere here. So these two angles will have the same value of sine. Both are positive, so they have the same sign of number also. So sine 120 degrees is exactly same as sine 60 degrees. Sine 120 degrees is same as sine 60 degrees, right? So sine 120 is root 3 by 2. So this can be written as sine inverse of sine 60 degrees. Now 60 degrees lies in the range of sine inverse. Now these two gets cancelled and the answer is 60 degrees. So sine inverse of sine 120 degrees is 60 degrees. Similarly, you have sine inverse of sine of 150 degrees. So corresponding to 150 degrees, the ray lies here, but this ray lies outside the range of sine inverse. So corresponding to the value of sine 150, I want a particular angle within this range whose sine is same as sine 150. That is nothing but the allied position, right? So the allied position of 150 degrees in the first quadrant is 30 degrees, right? That is just the mirror image. The mirror image of 150 degrees ray on the first quadrant makes an angle of 30 degrees, right? So sine inverse of sine 150 is exactly equal to sine 30 degrees. Now 30 degrees is in the range of sine inverse and the answer is 30 degrees. So sine inverse of sine 150 degrees is 30 degrees. Now if you go to further angles, for example, sine inverse of sine of 210 degrees. So where does 210 degrees lie? So the ray correspond to 210 lies here. Correspond to sine 210. The value is negative because 210 lies in the third quadrant. Now within minus 90 and plus 90, what is the angle which has the same value of sine as sine 210 degrees? Because this is in the negative quadrant of sine, the reflection has to go on to the negative side, right? So 210 degrees is 180 plus 30, so this angle numerically is 30 degrees and this angle numerically is 30 degrees, but it is measured in the negative direction. So this ray corresponds to minus 30 degrees. So sine 210 is exactly equal to sine of minus 30 degrees. Now minus 30 lies in the range of sine inverse and the angle is minus 30 degrees. So I hope you understand the basic process, how to simplify the expression of the form T inverse of T if this angle is not in the range of a particular trigonometric ratio. So now let us look at more examples and see the quadrant diagram for each of the different trigonometric ratios.